Router IDs must be unique. Okay, great. Must be match. Okay. Subnet mask should be match. Okay. MTU must match. Area ID must match. Okay, what will happen if MTU will mismatch? Okay, before that, tell me the next parameters for neighborship. Area ID, router ID must be unique. Hello time, date time must be same. Subnet mask must be same. Area ID must be same. MTU must be same. Then network type must be same. Then OSPF authentication type, authentication data must be same. Stub flag must be same. Anything else? Today OSPF, first let me cover the states, then we'll move to LSAs. And while talking about the state, we will also understand the LSAs. Okay, so before that, let me test your knowledge about the basic parameters. Are clear? Done. Then guys, how many types of areas are there in OSPF? Okay, what will be the parameter in hello message? What content hello message will carry? Router ID, authentication type. Okay, and what will be the by default priority? By default priority value. Okay, dr router ID, then hello time, date time. Backup designated. Okay, okay, correct. How many messages are there in OSPF? Messages. Type 1, type 2, type 3, type 4, type 5. Which message is type 1 message? Type 2? Guys, please type the name of all messages in chat. Just let me check. Please type name of all messages in chat. Do fast. Yes. Types of messages in OSPF. Then we had seen router ID as well. Router ID is 32 bits, address represented in IPv4 format. hello dbd lsr lsu lsac. Type 1 type hello, type 2 dbd, type 3 lsr, type 4 lsu, type 5 lsac. Good. Okay, how many method we have to configure OSPF for our ID? Three method. Two, static and dynamic. In the dynamic, how router is going to elect router ID? Tell me the dynamic method. Highest loopback IP address. Then yes, if loopback does not exist on the router, then it will check IP address on physical interface. Correct. If multiple interfaces are there, then it will check highest IP address. Highest IP address will be elected as router ID. And if there is no physical interface configured, guys, yes, 0.0.0.0. And OSPF does not share their database with this router ID with 0.0.0. So now let's begin. State. Tell me how many states we have. OSPF states. Number 1, down. Number 2, attempt. Attempt is the OSPF state only in case of static neighborship. Leave it for now. Later I will tell you more about the attempt state. For now, yeah, init after that attempt. Sorry, init, then attempt, after that two-way. So tell me if MTU will mismatch between two router, then what will happen? In which state neighborship will stuck? No. Yes, bro. In access start state. In two-way state, what will happen? Routers are going to check their own router ID in the received hello message. Routers are going to check their own router ID in the received hello message. After that, after two-way, access start. Access start. Then exchange. Then full. Full state means database has been exchanged between two router, right? So see guys, the meaning of down state here. OSPF state means OSPF uses a series of states to establish and maintain neighbor relationship with routers. These steps are part of OSPF neighbor adjacency process, which ensures that router have synchronized and accurate routing information. First state is down state. Down state means the initial state where no OSPF hello message has been received from the neighbor. How to verify it? If I will enable OSPF on order number 1 and not enable on order number 2, then what will be the state? Do so IP interface brief exclude unassign. We don't have IP. Interface F0/0 say no such, and IP address 12.1.1.1 255.255.255.0. exit. Router OSPF process ID 1. Process ID is locally significant, and you can see the range of process ID over here. It is 16 bits value. 16 bits value, so range is 1265535, right? Say 1, and after that router ID 1.1.1.1. How to verify router ID, guys? Do so IP protocol, right? Router ID is 2.2.2. Now I am going to enable OSPF on fast Ethernet 0/0. How many options I have? 2. One with the help of network command, and another way is on the basis of interface, right? So let me use network command here, network 12.1.1.0. Now what next? Subnet mask or wildcard mask? What will be wildcard mask? Then area. If I am saying area 256, how router is going to denote area? What will be configure area on router number? How router is going to configure area? 256. Yes, it is. Area ID is represented in IPv4 format. So area ID is going to be 0.0.1.255. But for now, just I am advertising this interface in area 0 in backbone area, right? And now, so IP OSPF interface brief. State here is waiting. I am not talking about this state. This is not a state of neighborship. This is not a state of neighborship. This is a state for DR and BDR. We will see it later, right? For now, so IP OSPF interface fast Ethernet 0/0. Here it will show you the state. What is the state? Now this is a question for you guys. How to check OSPF neighborship down state? Here also I am able to see the waiting. This is for DR and BDR only. This is not the state of OSPF neighborship. Okay. So write down this question. Tomorrow I will ask you. Otherwise I will explain tomorrow. I am not able to see anywhere state is down. But as this router is only sending OSPF hello message from fast Ethernet 0/0, as it is not receiving any hello message on this interface will consider as down in OSPF. So the difference between enabled OSPF on interface and disable OSPF on interface is enable means it is sending the hello message. Disable means it is not sending the hello message. But down state means not like OSPF is not enabled here. OSPF is enabled, but it is not receiving any hello message. Now question is, if there is no neighborship between router 1 and router 2, you need to troubleshoot OSPF neighborship. So router OSPF neighbor, there is no neighborship. Now you are going to troubleshoot it. Why there is no neighborship? So you need to check state of fast Ethernet 0/0. So how you will check it? This is a question, okay? Keep in mind. Now next state is down state. Is hope down state is clear. Means sending hello message but not receiving any hello message. How to verify? Debug IP OSPF hello, and it will send hello message on what address? What will be the address? Destination IP address. What will be destination IP address, guys? Multicast. Which multicast? Because we have two multicast address for OSPF on this multicast. 5. As I told you, all router will listen on this multicast address 224.0.0.5. Yes, go ahead, bro. Boy, not other. As you have enabled OSPF on this interface, router will start sending hello message to discover the neighbor. The two use of hello message, right? It is not sending hello message to their neighbor. Right now router is trying to find neighbor here on the OSPF enable interface. Once it will discover neighbor over here, then it will send hello message to their neighbor, right? So in that hello message, router will send router ID of neighbor router as well, right? For the current hello message, router will only send their own router ID, like 1.1.1.1. This is my router ID. Till now, router have not discovered any neighbor on fast Ethernet 0/0. Got it, guys? And you can see the for the tubal sitting, this router is only sending the hello message, but it is not receiving any hello message, right? So you know, if router is not receiving hello message, then state is down. And so IP interface fast Ethernet 0/0. So you can see this interface is joined to multicast group, right? 224.0.0.5 and 6. 224.0.0.5 and 6. But the main multicast address of OSPF is this one, 0.5. Simply if I will configure priority 0 over here, interface F 0/0, say IP OSPF priority 0. By default priority is 1. If I will configure priority 0, then this router will not participate in DR and BDR election, right? Then this router will only listen for 5. We'll see this later, don't worry. Now next state is, and see more about down state. Example, a router in large corporate network is powered on and state its OSPF, start its OSPF process. At this point, it has not received any OSPF hello packet from the neighbor, right? Then guys, init state. Init state, once router will receive hello message on their interface, state will move from init to, down to init. The router has received a hello packet from a neighbor, but has not yet established bidirectional communication. What is the meaning of bidirectional connectivity? Bidirectional communication means router have received the hello message, but router have not seen their own router ID in the hello message, in the received hello message. Got it? To place. What is to place? Bidirectional communication. Bidirectional communication means, see, right now router is sending hello message. If you will open this hello message, router is sending only their on router ID. Correct, guys? Source OSPF router ID 1.1.1.1. Is there any information of active neighbor? No. But after receiving the hello message from router number 2, router will send again next hello message, and in that hello message you will see in the bottom there will be one more field, active neighbor, right? Remember the content of hello message, right? So it will add active neighbor router ID field there, and on router will see their own router ID in the hello message. State will move from init to two-way, right? State will move from init to two-way. So example, in data center, router A receive a hello packet from router B. Router A transition to the init state, but wait for router B to acknowledge its presence. So right now, when you will enable OSPF on router number 2, router 2 will send their first hello message without neighbor router ID. But in the next hello message, it will send neighbor router ID. So right now, when router 1 will receive first hello message from router number 2, it will wait for their own router ID. Until and unless router will not see their own router ID in the hello message, Until unless router 1 will not seen their on hello message, state will not move from init to two-way, right? So what I am going to do now, our router number 2 also I am going to configure OSPF. So config T router OSPF process ID 1, router ID 2.2.2.2 and network. First of all, I need to configure IP on F0/0. Otherwise, I have configured the router ID as well, but see this log message. As there is no loopback, there was no any physical IP address running. So router failed to start OSPF process because router is not able to elect router ID, right? So say IP address 12.1.1.2.255.255.255.0 and then router OSPF1 and network 12.1.1.0.0.255 area 0 debug IP OSPF events debug IP OSPF hello debug IP OSPF debug IP OSPF flood no hello monitor okay packets done. Now I am going to run this network command on order number 2. बीच में ही आ गया ये तो परवीन. Now router 1 is sending hello message. Soon it will receive hello message from router number 2. Is interface up? Do so IP interface brief exclude and assign. Do so IP interface brief. No, interface is down. So let me run no set command here on interface F0/0 say no set. Go to router 2. See, it is sending hello message. Soon router 1 is going to receive hello message. See the entire process. What happened, guys? All. It was sending hello. Here is the first received hello message. Received hello from 2.2.2.2 and in the captioning also you can see the first hello message of router 2. Where is the first hello message of router 2? Router 1, router 2. First hello message. There is no information of neighbor router ID, right? But in the second hello message, see the second hello message of router 2. Active neighbor router ID, right? So once router 1 will receive this hello message, it will see, oh, my on router ID is there. So this is how routers are going to check bidirectional communication in OSPF, right? And now state will move to two-way. So it have received the hello message. In this hello message, there will be no neighbor router ID, right? Send immediate hello message to neighbor. This is for acknowledgement. Immediate hello message. Then again send hello message to their neighbor and this time router will also add neighbor router ID in their hello message. This is hello message of router 2 to router 1. Then from router 1, router ID over the DBD received hello message from router number 2. See, after receiving hello message from their neighbor with their own router ID, what it's saying? Two-way communication to 2.2.2. State moves to two-way. right? And in the two-way state, DR and BDR election will happen. DR and BDR election will happen in two-way state. Now try to understand why DR and BDR election will happen. Suppose I have four router. Router 1, router 2, router 3, and router 4. It is very important for real-time network. Very important. Anyone have idea, guys, why we have concept of DR and BDR in OSPF? In the real time also you are going to connect devices like this. Can I ask you one general question of networking? One general question. Are you ready? Let me check your basic knowledge of networking. Guys, I need to connect three networks. Let's say this is my headquarter somewhere. Done. In the headquarter I have one router 1, right? Then I have let's say one partner network have this router 2. This is partner network, right? Then I have one, let's say, a small department here, branch office, or another building. Here also I have one router R2. Now, sorry, R3. Now this is my, let's say, branch 1. This is headquarter. This is partner network. Now I am going to connect these three network together. Should I connect like this? This is the one scenario. I can connect like this, yes or no? The another option is here I can add one switch. Then I can connect switch to headquarter router, and after that to router number 2 partner network and branch office 1. Now tell me, according to you, which design is the better? Hello? Oh my god, without switch. So sorry, brother. See, first of all, the issue over here. Guys, is there scalability? No. There is issue with scalability. Now let's suppose I have one another partner network and I want to connect them. So I need one more port on switch, sorry, on router. Correct? I need one more port here on the router. Maybe on the router actually generally you will have less port. Like this again, if you need to connect one more network, again you need one more port on the headquarter router. And now see, the headquarter routers are going to manage how many OSPF neighborship? 1, 2, 3, 4, right? So definitely load on headquarter router is going to be increased, correct? First issue is issue with scalability, and in upcoming days I will tell you the many more benefit of using switch here. So in real time you will use switch here. If you have switch here, but you can reduce the broadcast with the help of VLAN, right? I can put this port in different VLAN, this port in different VLAN, and this port in different VLAN. Now see, it is much better for scalability, right? Even I can connect 24 networks to headquarter, but to connect 24 networks or partner networks to the headquarter router without switch, I need 24 number of ports on router, which is not possible generally, right? On the router you will have less ports. Getting my point? So in up, yeah, Yeah, right now, see, router 1 is managing only one interface, right? Definitely, CPU will be less as compared to the previous scenario, and it is much better for scalability, right? For the growth. Now I can connect multiple networks with headquarter without major change. And placing one switch over here is much easier and much cheaper as compared to add port on the router. To add extra port on the router, you have to purchase the card module, right? Expansion module. And these expansion modules are very costly, guys. So it is much better to use one switch over here, right? So that's why what I am saying, I have a scenario like this. Let's say again, this is the network of headquarter, right? Where I have four routers. Four routers. Each routers are connected with, let's say, branch offices. Each routers are connected with branch offices. Router 1 is connected to India, router 2 is connected with US, router 3 is connected with different location, right? So like this, let's suppose this is my backbone network. This is backbone network, headquarter network, data center network, right? But what is the issue over here? Now try to understand the issue. There is one biggest issue. R1, R2, and using switch over here instead of connecting all routers together, I will teach you guys many more benefits, right, in the upcoming day. No, don't worry. In the even BGP, we will discuss these types of scenario. Now let's say here, this is multi-segment. So let's suppose here I am using this network 192.168.10.0/24. If I need 4 IP addresses, what should be my subnet mask? Tell me. If I need 4 IP addresses, then what should be my subnet mask? Please type in chat. What should be the subnet mask to get 4 valid IP addresses, guys? Okay, great. So you should use /29. Here IP address is, let's say, dot 1. Here IP address is dot 2. Here IP address is dot 3. Here IP address is dot 4. Now as I told you, router 1 is connected with any branch offices, right? Let's say here we have lots of subnets behind router number 1. In the same way, behind router number 3 also we have some subnets. Behind router number 4 also we have some subnets. Maybe subnets are directly connected or it is receiving from their neighbor. It is possible, right? Here networks are 10.1.1.0/24, 10.1.2.0/24, 10.1.3.0/24. Here networks are 30.1.1.0/24, 30.1.2.0/24, and 30.1.3.0/24. Here 40.1.1.0/24. Okay, this is my scenario. In this scenario, I am going to configure OSPF routing protocol. OSPF. Here also we have one subnet 20.1.1.0/24, right? So guys, OSPF maintain database where it is going to install the information of entire topology. Am I right? OSPF maintain database where it will install entire topology information. So router 1 will have entire topology information. Router 2 will also have entire topology information. Router 3, router 4, all routers will have information of entire topology. Now, how many neighbor are there of router 1? How many neighbor are there of router 1? 3, right? Router 1 have 3 neighbor with router 2, router 3 as well as with router 4. How many neighbor of router 2? Again 3. How many neighbor of router 3? Again 3. How many neighbor of router 4? 4. If I have 4 routers in one multi-access segment, then how many total number of adjacency are there, guys? 12. 12 number of adjacency are there, right? Now, let's say if this network bill goes down, when this network 10.1.1.0/24 will goes down, what will happen? See, routers share their network information in OSPF in form of LSA1. In form of LSA1. LSA is link state advertisement. Like remember, LSU is a type of message in OSPF. With the help of LSU update message orders here network information. So once this network bill goes down, first router will update their database. It will increase their database, means it will update their database with higher sequence number. It will update, let's say earlier sequence number was 10, so now sequence number will become 11, right? Then now router, it's a responsibility of router 1 to share the updated information to their neighbor. Am I right? Right, guys? So router 1 is going to share updated information to their neighbor, to router number 2, to router number 3, and to router number 4. Now when router 2 will receive the updated information, router 2 is also going to update their database, right? It will also increment in sequence number by 1. Now whenever router will update their database, it will inform to their neighbor. So router 2 is also going to send LSA1 to their all neighbor, to router number 2, router number 1, router number 4, and router 3. In the same way, router 3 have also updated their database. So router 3 is also going to increase sequence number by 1, and then it will update to their neighbor. Then router 4 have also received the updated information, so it will update their database. It will increment in sequence number by 1, then it will share updated information to their neighbor. This is what? This is LSA flooding. Now see the CPU utilization in this scenario, guys. Whenever a single network will goes down, or whenever a single network will come up, doesn't matter which change, whenever a change will occur in the topology, there will be LSA flooding. All routers are sharing their LSA1 to their all adjacent neighbor, right? So in this scenario, CPU utilization will increase and performance is going to be decreased, right? Now maybe branch offices users are not able to communicate with other branch offices user for some time, or there is latency issue, packet loss issue. The reason? LSA is flooding in the headquarter, and not only in the headquarter. These routers, maybe these routers have OSPF neighborship with branch offices routers, right? So it is going to share LSAs to their branch users as well, right? So in the entire network, there will be LSA flooding, right? And this flooding will decrease the performance. User will start getting latency issue, packet loss issue, slowness. And you are the network engineer, you will start getting call from the customer. Hey Bezat, what are you doing? See, the customers are not able to access the resources. I will fire you. Yes or no? Don't worry, I am teaching you now. So you will reduce this flooding in the network. You are not going to leave this flooding. You are going to fix it. So to fix this issue, guys, to reduce this flooding, we come up with concept of DR and BDR. Just take an example of a classroom. Let's say in a classroom there are 40 students, and a teacher is coming and he's asking, oh, hey, what is the date? So if all people will speak that today is 6th August, there will be flooding, right? So if there is flooding at the time of speaking, not two people can communicate with each other, yes or no? Because of the crowd. Yes or no, guys? Same thing happening over here. So that's why to reduce the flooding in classroom, so that whenever someone will ask for something, only monitor is going to reply. Yes or no? In the class, we are going to elect one student as monitor. And whenever someone will ask something, monitor will only reply. Yes or no? Tell me, guys, yes or no? If yes, then same concept we need to apply over here. We need to select one router as a monitor router, and that monitor router is known as DR router. So only DR router is going to form full adjacency with DR others. All other router will become what? DR other. Now R1 is my DR. This router is DR other. DR other. DR other. DR other. So DR other and DR other will form neighborship till two-way state. Right? Two-way state. And you know in two-way state routers are not going to exchange update message, right? Database. And DR router will have full adjacency with DR others, right? So here we have full adjacency. Here we have full adjacency. Here we have full adjacency. So this is the two types of neighborship in OSPF. See, router 2 and router 3 are neighbor in OSPF, but without adjacency, right? These are neighbor without adjacent. These are not adjacent, only neighbor. But neighborship between router 1 and router 2 is adjacent. Neighborship between router 1 and 3, full adjacent. Neighbor with adjacent. Between router 1 and router 4, neighbor with adjacent. And now if this network will goes down, router 1 is going to update their database with higher sequence number 11, then it will share the updated information to their neighbor. Means to router number 2, to router number 3, and to router number 4. Now these routers are not going to share that updated information to any other router, right? Because router 2 don't have any other neighbor with full adjacency to whom it can share database. So with the help of DR, how many number of adjacencies are there? Only 3. How many total number of OSPF neighborship are there? 12. Got it, guys? Yeah, go ahead. So that's why we have BDR, na brother? BDR, backup designated router. So see in the classroom, what is problem? What if monitor is absent? So I need one backup for monitor, yes or no? So in the same way, I can configure one router as backup router, right? Backup DR router. But first of all, tell me which router is going to become DR. Which router should be DR in the network? So guys, as DR router is going to manage the full adjacency neighborship, DR router is main router. Definitely load on DR router will be high. So router, you need a high processor router for DR. So router who have good memory, good processor, good CPU, that router should become DR. And you will learn how to configure a router to become a DR, right? But otherwise, these routers are going to perform election for DR and BDR. Automatically one router will become DR, right? So again we have two options like router ID to configure DR and BDR. One is dynamic. In dynamic, router itself perform election, and one router will become DR, another router will become BDR. But on the second way, manually we can configure a router. I can tell to router 1 you will be the DR only, right? Router 4 you will be the BDR router only. And even I can configure these two router, right, to not participate in DR and BDR election. So if you will configure priority 0 on the router, that router will never participate in DR and BDR election. Got it? But first thing, you should have knowledge about why DR and BDR. Interviewer can ask you, right? Maybe you need to configure DR and BDR in the real time in the production network. So until and unless you don't know the use case of DR and BDR, how you can implement it, this is not like running command only on the router, enabling OSPF only. No, as OSPF is most important routing protocol nowadays. Everywhere, guys, in the small network, in the medium network, and in the large network, in the enterprises network, in the service provider network, OSPF is most important routing protocol. ISPs are also using OSPF as their IGP protocol, Interior Gateway Routing Protocol, right? So why we come up with DR and BDR? Tell me the two reason why we come up with DR and BDR. Two reason. Yes. And how to increase the performance? How to reduce the CPU with the help of reducing the number of adjacency, right? With the help of neighborship adjacency. So first reason behind DR and BDR is reducing number of adjacency. The second reason to reduce LSA's flooding, right? Or not LSA's, LSA1. Don't worry, you will understand this also. What is LSA1? Soon we are going to start LSA, okay? So these are the two reasons. And guys, DR and BDR election will happen in which case, in which state? In two-way state. In two-way state. See here. Earlier router 1 was sending only hello message. It have received hello message from 2.2.2, first hello message. Then it have received the second hello message from 2.2.2. And in this hello message, it will see their own router ID. So once it will see their own router ID, bidirectional communication has checked, state will move to two-way. And in the two-way state, see DR and BDR election, right? And this router is elected as, router 1 is elected as DR router, right? See, elected BDR 2.2.2, elect DR 1.1.1. DR and BDR election will happen in two-way state. After two-way communication, first it will check two-way communication, then DR and BDR election will happen. Then next thing, it is sending what? DBD, database description. Why database description? To exchange sequence number. To exchange sequence number. Now, before talking about the DBD, After DR and BDR election, once a router will become DR and one router will become BDR, a state will move to X start. Two-way to X start. And guys, tell me, in this scenario, is DR and BDR required? Is DR and BDR required over here? Not required, right? DR and BDR is not required, but still routers are performing DR and BDR election. So definitely if router is performing DR BDR election, means it is using their CPU utilization, right? So as a network engineer, first of all, in this scenario, you should disable DR BDR election, right? You should disable DR BDR election. How to disable DR BDR election? By changing the network type. By default, network type over here is network type on broadcast, means sorry, on the fast Ethernet link is broadcast, right? So on the broadcast network type, router will always perform DR and BDR election. Not you can say on fast Ethernet link, router will always perform DR and BDR election. In the broadcast network, router will always perform DR and BDR election, right? Now to disable the DR BDR, what we can do? We can change the network type. We should configure what network type over here? Network type of OSPF. Point to point. Very good. As both routers are connected with a single link, like point to point, so network type should be point to point here, right? Once you will configure network type point to point here, DR BDR election will not happen. Done. Now question is, which router will become DRC? Between router 1 and router 2, both routers are performing DR BDR election, and router 1 is my DR router, correct? Router 1 is the DR router. Router 2 is the BDR router. Why? How? Anyone? On the serial link, OSPF network type is what, guys? By default, on the serial link, point to point. Yes, point to point. On the serial link, by default network type is point to point. Yeah, tell me. What was the question? So first state is down state. Down state means, yeah, DR and BDR election. Yes, tell me DR and BDR election. Anyone have idea? Tell me at least no. Don't have idea about it. Okay. So see, in this scenario, router 1 router ID is, let's say what, 1.1.1.1. Router 2 router ID is 2.2.2.2. Router 3 router ID is 3.3.3.3, and router 4 router ID is 4.4.4.4. For DR and BDR election, first of all, routers are going to check highest DR and BDR. Highest priority. Bezad, you have already did your CCNA, right? So at least I am expecting this type of answer from you. And like Tom, right? So highest priority, range of priority is Priority is, guys, 8 bits value. Priority is 8 bits value. So range can be 0 to 255. And the by default priority is 1. Right? So now priority on this interface is also 1. Priority on this interface is also 1. Priority on this interface also 1. Priority on this interface is also 1. So priority is tie. Then how routers are going to perform DR and BDR election? Based on router ID. Now, as you know, router ID is unique. Right? Two router cannot have same router ID. So on the basis of router ID, routers are going to perform DR and BDR election. So highest router who will have highest router ID, that router will become DR. And the router who will have second highest router ID, that router will become BDR. And rest all router will become DR other. Rest all router will become DR other. Now question is, in this scenario, router 1 have router ID 1.1.1 and router 2 have router ID 2.2.2. Then how router 1 is the DR router? Right? Guys, in this scenario, priority will tie first of all. So IP OSPF neighbor. So IP OSPF interface brief. By default priority is 1. So IP OSPF interface F0/0 include priority. By default priority is 1. On router number 2 also you can check. By default priority is 1. So priority is tie between router 1 and router 2. Then it will perform DR BDR election on the basis of router ID. But router 2 have higher router ID. But in my case, so IP OSPF neighbor. See, router 1 is the DR router. Why? Right? See the state of router 1 DR. So IP OSPF interface brief. Router 2 is BDR because of timer. Right? So guys, a router will wait for DR and BDR election till dead interval. And by default dead interval is 40 seconds. Right? So once you will enable OSPF on router number 1, router 1 will wait for 40 seconds for the DR and BDR election. Within 40 seconds, if router will receive a hello message with higher router ID, then it will not declare their self as DR. But if router 1 will not receive any hello message with higher router ID within 40 seconds, then router 1 is going to declare their self as DR. और एक बार जब प्रधानमंत्री का इलेक्शन हो गया तो किसी का बाप भी उसको नहीं बदल सकता है कि नहीं? In the same way, once a router is elected as DR, no one can replace their role. Getting my point? So router 2 have to become BDR. Right? So in this scenario, if you will configure OSPF on router number 1, and if router 1 will not receive any hello message with higher router ID within 40 seconds, then router 1 is going to declare their self as DR BDR. So for correct DR BDR election, for automatic correct DR BDR election, you have to enable OSPF on all routers within 40 seconds. Yes or no? You have to enable OSPF on all routers within 40 seconds. Then only router 4 is going to become DR and router 3 is going to become BDR. Right? But let's say first I have configured OSPF on router number 1. Right? So router 1 have become the DR, and then I am configuring OSPF on router number 2. So router 2 will become BDR. Then I am configuring OSPF on router number 3. But router 3 will become DR other. Even router 3 have higher router ID, but this router will become what? DR other. Router 4 will also become what? DR other. DR other. Clear? And now if any change will occur on DR other, let's say if this network will goes down, router 3 will update their database with higher sequence number 11, and then it is going to share the updated information with their full adjacent neighbor. Who is full adjacent neighbor? DR router. So router 3 will share updated information to router number 1, and router 1 will pass that information to their other neighbor, to router number 3 and router number 4. So see the LSA transmission now. Done. And if you don't want to participate router 2 and router 3 in DR BDR election, what you can do? You can configure priority 0, right? So what will happen? See, in this scenario, if I want to not participate in DR BDR, router 2 and router 1 and router 2, can I configure priority 0? Interface F0/0, say IP OSPF priority 0. On router number 2 also I am going to configure priority 0. Interface F0/0, say IP OSPF priority 0. See the issue now. What will happen? So IP OSPF neighbor. We have neighborship. No. Neighborship is stuck in two-way state. Now it will not move from this state. Right? And as a network engineer, now how you are going to troubleshoot it, bro? Neighborship is stuck in two-way state. This time issue is what? Issue is OSPF is running on the broadcast network type. So on the broadcast network type, DR must be exit. DR must be exist on the broadcast network. If there is no DR on the broadcast network, then there will be issue. And same issue here I am facing. Right? So to stop DR and BDR election, you cannot configure priority 0. Right? Priority 0 is used to configure a router to not participate in DR and BDR election. But guys, on the broadcast network, DR and BDR is required, right? So see now, so IP OSPF database. Clear IP OSPF process. Yes. Wait for some time. Now you can see, so IP OSPF neighbor. Neighborship is in two-way, so IP OSPF database. Now router 2 have their own LSA only, right? In the same way router 1, so IP OSPF database. Clear IP, this is old entry. Clear IP OSPF process. Because in two-way state, routers are not going to exchange any update message. So IP OSPF neighbor, so IP OSPF database. Right? So IP OSPF neighbor. So IP OSPF interface fast Ethernet 0/0. Issue is DR other. On router number 1, so IP OSPF interface F0/0. Issue is state waiting, so this router will also become DR other, but network type is broadcast. So in broadcast network, DR must be exist. So we cannot configure like this. We cannot configure priority 0 over here. Interface F0/0, say IP OSPF priority 0. I am going to remove this command. No. On router number 2 also. Interface F0/0. No IP OSPF priority 0. Now see, so IP OSPF neighbor. Now neighborship is in full state, but there is DR and BDR, right? DR and BDR. So IP OSPF neighbor, but I don't want DR and BDR over here in this scenario. So simply I can change network type. Say interface F0/0 IP OSPF network point to point on order number 2 also. IP OSPF network point to IP OSPF interface F0/0 IP OSPF network point to point. Now, so IP OSPF interface F0/0 include network. Network type is point to point on order number 1 also. So IP OSPF interface F0/0 include network. Network type is point to point. So IP OSPF neighbor. Neighborship is full, but there is no DR now. DR and BDR. So IP OSPF database. Database is here. So IP OSPF neighbor. There is no DR and BDR now, right? And so IP OSPF interface F0/0. Now state is now point to point, not DR and BDR, right? And see the wait time is 40 seconds. This is the wait time for DR and BDR election. Router will wait for 40 seconds. So in two-way state, routers are going to perform DR and BDR election. After performing DR and BDR election, state will move to X start. In X start, what will happen? Again, I am going to debug IP OSPF events, and on order number 2, clear IP OSPF process. Yes. Oh, debug IP OSPF packets, debug IP OSPF packet is done. Then events, then what next? We can say adjacency. Done. Now again I am going to clear IP OSPF process. Clear IP OSPF process, say yes. Go to router 1 and see the all process very carefully. Now say on all. Now this time, see there is no DR and BDR election, right guys? So here is the two-way state. Two-way communication has checked. Now router is sending directly what? Send DBT to 2.2.2. So router 1 is sending DBT to router number 2. And sequence number is this one, right? So actually router exchange DBT message to exchange sequence number. And one more thing will happen in this state, in X start state, that is election of master and slave router. Election of master and slave router. See, first router have sent DBT to 2.2.2. Then this router have received DBT from 2.2.2. And after that, we are slab. This router is elected as slab router. And router 2 is elected as master router. Election is exactly same like DR and BDR. Now question is, why master and slab election? Why master and slab election? See guys, in this scenario, OSPF is running on all routers. There is no DR and yeah. Really? What about others? For rest all, it's working fine, bro. Just wait for 2 minutes. Maybe there is some internet issue from your side. Just exit from the meeting and then rejoin. Okay, then I think it will work fine. Done. So guys, in this scenario, all router have their on database, right? First state will come in down, then it will move to init, then it will move to two-way. In the two-way, routers will perform DR/BDR election. After that, state will move to X start. In X start, all routers are going to exchange database. Mhm. DR or BDR का? So definitely see now, if BDR router is going to become DR whenever DR router will goes down. So definitely there should be full neighborship, right? So that these two router can exchange entire information. There will be full neighborship state. Two-way. Yes. DR other and BDR I am saying only. What was your previous question? Between DR and BDR, we will have full state neighborship, right? But this is, let's say, BDR. Here is the BDR, sorry. Here we will have full state. Here we will have two-way state. We'll do one lab of this scenario as well, right? Now guys, in X start state, okay, state will move to X start from two-way after election DR/BDR. Then in X start, all routers are going to exchange sequence number. Now router will have DBD of their neighbor. Like router 1 will have DBD of router number 2, means 2.2.2.2 with sequence number, let's say 1. What is the use of sequence number? To reduce the LS, algorithm execution, right? SPF algorithm. Why? Because if router 2 have the database of router 1 have database of router 2 with sequence number 1. So until and unless router 1 will not receive database of 2.2.2 with higher sequence number, it will not run SPF algorithm on their database, right? Once router will receive the update message from 2.2.2 with higher sequence number, then it will get to know, okay, there is some updated information, right? So both routers are going to exchange sequence number in X start state, and then after exchanging sequence number, it will perform master and slab election. Why master and slab election? So that we can identify which router will initiate the LSA transmission. Actual message is LSA message, that is LSU, LSR, and LSAC. These are the three messages used to share network information, right? So like in my scenario, if router 1 will become master router, but router 2 is the master router here, master and slab. So router 2 is going to initiate LSA transmission. Got it? Router 2 will initiate LSA initiation. So in the X start state, both routers are going to send DBD. This router will also send DBD. Now it will perform master and slab election. In this state only routers are going to negotiate what? MTU. So if MTU will mismatch, then neighborship will stuck in which state? X start state only. Right? I have an interview question. Right? Can OSPF neighborship stuck in init state? Init state? Bro, DR, BDR in two-way state, na? There is very less chance to stuck OSPF neighborship in init state. Yes, but neighborship can stuck. But you know the reason to stuck neighborship in two-way state. What is the reason? Maybe priority is 0, 0 on the broadcast network. Then routers cannot elect DR and BDR on the broadcast network, but DR and BDR is required there. So neighborship will stuck in two-way, right? Then state will move to X start. Can OSPF neighborship stuck in X start state? Yes. Reason can be MTU, right? But if MTU is same, router have performed the master and slab election, then state will move to exchange state. Exchange state. And in exchange state, routers are going to exchange what, guys? Hmm? Header of network. Router will exchange header of network, right? So router 1 is going to send header of this network, router 2 is going to send header of this network in exchange state. Then state will move to loading. And header means, as I told you, just like menu card, means router will share their link connected available links states. Like let's say router 1 have 100 number of networks in their OSPF database. So router 1 is going to share header for all those 100 prefixes, right? Like router 1 is telling to router number 2 that brother, I have these all subnets like 10.1.1.0/24, 10.1.1.2. Sorry, 10.1.2.0/24, like this. And then router 2 is going to check, okay, router 1 have these all information. Do I need any network information? If yes, then I have to send what? LS or message, link state request message. And after that, router 1 is going to send actual update message, that is LSU. And in this LSU, router will share the detailed information, right? Detailed information of all links. In the LSA header, it will share only header information, right? Like in the restaurant, you want to order a burger. So first you will get menu card. That is just a header of all available foods, right? You cannot eat menu card, correct? Because this is not actual burger. This is just a header. Actual burger. When you will send the request message, then you will get what? Actual burger. Yes or no? Same thing is happening over here. When router 2 will send the request message, then router will send those network information, detailed information of those networks. So this is what partial update. Router will only share those network information for which it have received request message, right? not like EIGRP or distance vector routing protocol, sending entire routing table every time. Let's ले 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 वो भी पीरियोडिकली। भाई दे तो दिया, सबर कर ले थोड़ी देर, है कि नहीं? क्या करेगा वही सेम इंफॉर्मेशन बार बार लेके एक राउटर, राइट? अननेसेसरी सीपीयू यूज हो रहा है, लिंक की बैंडविड्थ यूज हो रहा है, right? So actual network informations are inside the LSA. And what do you mean by actual link information? See guys, like router 1 have one network here. So how router 1 is going to create their database? Actually it will create one database. In that database it will install the state of this link, like link is equal to loopback 1, right? State is up. Network which is running on this link is 10.1.1.0. Subnet mask which is running on this link is 255.255.255.0. Cost of this link is 1. So this is what? This is link state information. And OSPF, as OSPF is link state routing protocol, so OSPF is going to share link state information only. Done. And after exchanging the all messages, all database, state will move to full, from loading to full. So in access start, it will only exchange DBD and it will perform master and slab election. Then in exchange state, it will exchange header of LSAs. In the loading, it will exchange LSR, LSU, and LSAC. And after exchanging entire database, neighborship state will come in full state. Now, question: can OSPF neighborship stuck in loading state? Hardware issue. Guys, I was troubleshooting OSPF network, right, in the real time, and I had same issue. OSPF neighborship was in loading state. और कोई पढ़ाया भी नहीं था कि लोडिंग स्टेट में कभी स्टक हो सकता है. And then I realized that this was just because of hardware issue. You know this link? This link is receiving traffic as well as forwarding traffic. This port is receiving traffic as well as forwarding traffic. That means there are two pins. One pin is responsible for receiving the traffic, one pin is responsible for forwarding the traffic. Let's say if one pin is not working, let's say receiving pin is not working, in that scenario it will show you their status and line protocol up, status and line protocol up. So this can be also one scenario that you are able to see their status and line protocol is up, then also communication is not working, right? There's no communication. So maybe TX or RX pin is not working there. So sometime, but it is very rarer, right? Generally, you will see OSPF neighborship is stuck in two-way, then access start only. An interviewer will also ask you question from these two state only. That OSPF neighborship is stuck in two-way state. What can be the reason? So now you know the reason can be hello, yeah, and in access start state MTU mismatch. So you can configure these things. I have already show you the neighborship in two-way state. Simply you can configure priority 0 on the broadcast network. You will have same issue. Mhm. If R1 link will goes down, then how R1 can send any message to it? First it will update their database and then it is going to send LSU. Done? Yes. Now types of LSAs in OSPF. Right? So now I'm expecting guys all states are cleared. Yes, yes, go ahead. Yeah. Difference between DR and BDR. No, no, DR router is responsible to share OSPF database to DR other routers in the broadcast network. And master slab router is master router will initiate exchanging LSAs first. Right? These two are completely different thing, brother. Now types of LSAs. Types of LSAs. So type 1 LSA, type 2 LSA, type 3 LSA, type 4 LSA, type 5 LSA, type 6 LSA, type 7 LSA, type 8 LSA, type 9 LSA, type 10 LSA, and type 11 LSA. How many LSAs we have? 11 number of LSAs are there in OSPF. Done. Type 1 LSA is the router LSA. Type 2 LSA is network LSA. Type 3 LSA is summary LSA. Type 4 LSA ASBR, ASBR LSA. Type 5 LSA external LSA for redistributed route. Type 6 M OSPF LSA. Type 7 NSSA LSA. And type 8, 9, 10, 11 is not for you. Right? In the quality of service, in the MPLS, like in traffic engineering, we are using these LSAs. CCNA to CCI, you need to learn these all LSAs, not M OSPF LSA as well, right? LSA 6 is also not for you. So how many LSA you need to learn? 6. LSA 1 to 5 and 7. LSA 1 to 5 and 7. Right? Now let's begin from router LSA. So guys, router LSA, there will be, see, before starting the LSA, let me give you some basic information, basic idea about the LSA. See, these all LSAs will carry two information. These all LSAs will carry two information. Number one, there will be there will be two information in every LSS. Clear? Number one, advertising router ID. Advertising router ID means who is advertising that LSA. Who is advertising that LSA router ID of advertising router. Second thing will be link ID. Link ID. Sometimes see advertising router ID will be always router ID of the router who is advertising that LSA. But sometime link ID will be the router ID. Sometime it will be router ID, or sometime it will be prefix information. Prefixes information means network information. We can say prefixes information subnets. Sometime link state ID can be router ID of the router who is advertising, or maybe neighbor router ID, or sometime it will be prefix information. But advertising router ID will be always the router ID of router who is advertising that LSA. And these all every LSAs carry these two information. Done? Clear? Any question? Now let's start router LSA. Any question? Please ask if anyone have any question. No? Okay, let's begin. Router LSA. Listen my each word very carefully, because router LSA is the most important LSA of OSPF, and every router in OSPF domain generates this LSA. Every router in OSPF domain generates this LSA. First point. Second point. Second point. What happened here? Second point. LSA1, which is router LSA, can be flooded within the area. It means LSA1 cannot cross the area. LSA1 cannot cross the area. Done. LSA1 cannot cross the area. Now I have two router, R1 R2. Both are directly connected like this. R1 R2. Router ID of router 1 is 1.1.1.1. Router ID of router 2 is 2.2.2.2. Done. Here IP address is 12.1. Here IP address is 12.1. 2. I'm running 12.1.1.0/24 subnet between router 1 and router 2. See guys how router 1 is going to create their LSA 1. So this is LSA 1 of router 1, and here let's say we have one loopback as well on router number 1, that is 10.1.1.0/24. Right now this is LSA 1 of router 1 of R1, simply we can say R1. Done. Oh yeah. So as I told you, two information will be there in all LSAs. So there will be advertising router ID, first information, advertising router ID. What will be the advertising router ID, guys? 1.1.1 means router ID of router who is advertising this LSA 1.1.1. Then as I told you, second information, link ID. Link ID in LSA 1, link ID will be also router ID of the router who will advertise that LSA. So link ID is going to be what? Same, 1. Now these two information, now routers are going to install states of their links. So how many links are connected on router number 1? Two links are connected with router number 1. First link is link is equal to link number 1. Link number 1. What network is running on link number 1? 12.1.1.0 slash subnet mask 24, and cost on this link is cost 1. Then link 2, second link 2, 10.1.1.0/24, and cost on loopback interface, let's say 1. You can calculate it, what will be the cost here on loopback interface. I think cost is going to be 64. Let me check. Formula is same, reference bandwidth upon bandwidth of link. And is there anything else that I need to discuss? No, you can see synchronization with 2.2.2 and non-neighborship is in full state. Done. So IP OSPF database router 1.1.1.1. What is the cost on loopback interface for 10 network? Oh, 10 network is not there. Let me create the loopback interface. Loopback 1, say IP address 10.1.1.1 255.255.255.0 and say IP OSPF 1 area 0. I am going to advertise it in area 0. And now let me check again database. So this time it will install one new link. Here you can see, and cost is 1. So cost on the loopback interface is also 1. This is LSA 1 of router 1. In the same way, router 2 is also going to create their LSA 1, and then it will share with their neighbor. Now let me design one network here, very important. Let me disable the capturing. I'm going to connect one more network here, one more router here, or leave 2 router is also fine, right? OSPF is running, guys. See, I want to design the network, right, with the help of database. I have database of router 1 as well as router 2. Now so IP OSPF database, sorry, so IP OSPF database. See router LSA. Are you able to see router LSA? Yes. How many number of router LSAs are there? 2. This is router LSA of router 1 and this is router LSA of router 2. In the router LSA of router 1, how many links are there? How many links are there, guys? 3. But how many links we have on router number 1? 2. So actually This time router 1 and router 2, both routers are considering their neighbor as a link. Both routers are considering their neighbor as a link, right? So that's why it's saying total number of link in the router LSA of router 1 is 3 and total number of link in the router LSA of router 2 is 2, because on router number 2 we don't have any loopback. Let me do one thing, let me create one loopback on router 2 also. IP address 20.1.1.1 255.255.255.0 IP OSPF 1 area 0. Now again go to router number 1 and check their database. So IP OSPF database. Now number of link in the router LSA of router 2 is also 3, right? So this is the first command. So IP OSPF database, right? Right now we have two routers, right? We have two router because you can see there are two number of router LSA. That means in this area how many routers are there? Two routers are there, right? So by checking database of a router can identify how many router belongs to this area. Yes or no? Guys, router can design entire topology by checking their database. Now I am going to open this in detail. This is just a header, right? This is header information. How many links are there? What is the sequence number and advertising router ID and link ID. So in the both router LSA we have these two information, advertising router ID and link ID. And link ID as well as advertising router ID is nothing but the router ID of advertising router. Done, right? So with the help of LSA1 or with the help of their database, router can identify one thing, that how many routers are there in this area, right? EIGRP cannot not check it, right? EIGRP can only learn routes from the neighbor. EIGRP don't know how many routers are there in the network. RIP don't know how many routers are there in the network. All routers are dependent their neighbor. Now let me open the LSA1 of router 1 in detail. So command is router, so IP OSPF router, sorry, LS database, and then in database I want to open router LSA. So say router and then router LSA of 1.1.1.1, router LSA of 1.1.1.1. You will always open LSA with the help of link ID. We will always open LSA with the help of link ID. Like I want to open LSA1 of router 1. So I will say link ID of router 1 is this one. So show me the router LSA of this link ID. And this is the link ID of router 1. Now see the detailed information. What it's saying? First of all, router OSPF with ID 1.1.1, process ID 1.1. Got it. That means there is one router 1 whose router ID is 1.1.1.1. This is the router LSA of router 1, right? Router ID 1.1.1. What is the process ID? 1. OSPF process ID 1. Then how many total number of links are there? 3. Total number of link 3. Now link connected to a stub network. A stub network means directly connected network. Means a network is directly connected with me, where network ID is 10.1.1.1. Subnet mask is 255.255.255.255. If you want to change it, simply we can do one thing, like on loopback 1 interface loopback 1, say IP OSPF network, let's say point to point. On the loopback interface also I have changed the network type. On the loopback interface OSPF will always advertise network with /32. Now open it. See, link connected to a stub network means directly connected link. It is talking about directly connected link where network ID is 10.1.1.0/24. subnet mask this one, right? So a link is connected with router number 1 where network is 10.1.1.0/24 and metric on this link is 1. Got it? Then another link connected to another router, that means it is talking about neighbor. So I am connected with another router R2. It is talking about R2 whose router ID is advertising router ID, neighbor router ID, whose router ID is 2.2.2.2, right? And the IP address which is running on my interface is 12.1. Okay, so that means IP address over here is 12.1. Then link connected to again a stub network. Actually it is talking about the neighbor. Leave it for now, we will discuss it later. But see the cost on this link, 1. Cost on this link is also 1. So with the help of their own router LSA, router can design this topology, right? But there are many more information. So now router 1 is going to open router LSA of router 2. So let me say IP OSPF database, and this time router LSA of 2.2.2. Okay, so what process ID is running on router 2? Same 1, right? Even router have information of process ID, which process ID is running. Then this is the LSA header, right? This is the LSA header. See, in the header there are information of total number of link, advertising router ID, and link ID, link state ID. This information will be there in the header. Then link connected to a stub network means again directly connected. That means from the router number 2, see I am on router LSA of router 2 2.2.2 and link connected to a stub network means router 2 is connected with one directly connected network where which network is running 20.1.1.1. It's say simply you can change the network type on router number 2 to make it LAN interface. Loopback 1 says IP OSPF network point to point. Now again let me open the LSA2. Just wait, soon it will receive the update message. Link connected to a stub router means router 2 is connected with one directly connected network where network ID is this one. Soon it will update their database. Network ID is for now this one, let's say /32, because on the loopback interface OSPF will advertise network with /32. Then link connected to another router whose router ID is 1.1.1. Definitely it is talking about me, right? My router ID is 1.1.1 and the IP address on their interface is 12.2. Okay, so IP address on router 2 is 12.2 and cost is 1. Then link connected to a stub network. It is talking about again neighbor router means router number 1. So see guys, is there any difference in this topology and your actual topology in the GNS3? Is there any difference? No. That means router can design topology with the help of LSA1. Got it? Got it everyone? In the same way router 2 is also going to generate their LSA. After exchanging the LSAs in the database of router 2, how many LSA1 will be there? 2. In the database of router 1, how many LSA1 will be there? 2. In this scenario, in the database of router 1, how many LSA1 will be there? Means router LSA 4. Even in the database of all router, there will be 4 LSA1. 1 LSA1 of each router. Got it? Got it guys? if I have a topology network like this, router 2 is connected with router 3 here, and router number 3 also I am running OSPF routing protocol. So how many LSA 3 will be there, sorry, LSA 1 will be there in the database? How many LSA 1 will be there? So see, anyone can ask you, interviewer can design, draw this diagram on the paper, and they can ask you, tell me how many LSA 1 will be there in the database of router 1. Yeah, go ahead. How many LSA 1 will be there in the database of router 1? Back यार सेट यार, एक तो LSA router 1 का है, 3 ना. All router will have one LSA 1, right? A stub network means directly connected network. Link connected to another router means it is talking about neighbor. It will consider their neighbor as a link in case of point-to-point network type. In case of point-to-point network type, see, if I will change the network type over here on router number 1, I'm going to say interface F0/0 IP OSPF network broadcast, that is by default network type. On router number 2 also interface F0/0 IP OSPF network broadcast. Done. And say clear IP OSPF process. Say yes. Just wait for neighborship. Now this time one router will become DR. So IP OSPF neighbor. So that's why this process is slow, because it will perform DR and BDR election. It will take some time to come in forwarding state. What is the priority on this router, guys? I think 0, right? So IP OSPF interface F0/0 include priority. Priority is 1, that is fine. So IP OSPF interface F0/0 include priority is 1. So IP OSPF neighbor. Neighborship is now full. So IP OSPF neighbor full, and so IP OSPF database. Now how many links are there in the router LSA of router 1? 2, right? So on the broadcast network, it will not consider their neighbor as a link. And once I have configured network type broadcast, there is one more LSA, that is network LSA, LSA 2. So LSA 2 is the concept of DR and BDR, right? If there is no DR and BDR, then there is no LSA 2 in the database. If there is DR BDR, that means there should be LSA 2 in the database. So like as I told you, every router in the OSPF domain will generate LSA 1. Like that, DR router will generate what? LSA 2. DR router will generate LSA 2. Why DR router will generate LSA 2? To share other routers information, means how many routers are there in this segment. See, router 1 is my DR. Router 1 is my DR, so router 1 will form full neighborship with all other routers. But here, neighborship will be in two-way state, correct? Fine, guys. Now, router 1 is going to share their LSA 1 to all other routers. Router 2, router 3, router 4 are going to share their database to router number 1. Will router 2 and router 3 exchange their database? No, never. Right? Then how router 2 will get to know how many routers are there in this segment. So that's why DR router will generate LSA2. LSA2 to share router information. In the LSA2, it will carry router ID of router 1, router 2, router 3, router 4. That's it. LSA2 does not carry link information, right? Means information of network. Even all odd number LSAs, like odd number LSA means LSA1, LSA3, LSA5, LSA7. These all odd number LSAs are used to share network information, and all even number LSAs are used to share information of router. Are used to share information of router. Like network LSA is used to share available routers in the segment. LSA4 used to share information of a special type of router in OSPF, that is ESBR, right? And all odd number LSAs, LSA1, like you can see LSA1 is sharing link state information. Done. So LSA1 is clear? All? Tell me. Should I start LSA2 today or tomorrow? Tell me, guys. Tomorrow? Okay, okay, okay. No problem. We'll start tomorrow. But now you can see the LSA means database of router, and now you can read the LSA 1. This is LSA 1. LSA 1 of router 1. Advertising router ID, link ID. Both are router ID of the router who is advertising that LSA. Then age is there, sequence number information is there, checksum is there. Checksum, you already know the checksum, right? Checksum is used for security purpose. It will put the information in algorithm and then it will find one value, hash value. It will match that hash value. If hash value is same, that means information is not modified. That is the use of checksum here as well. Then link, total number of link. Link count is 2 in the LSA 1 of router 1 as well as router 2. If I will add any more link here, interface, loop back 2. So see, router 1 LSA have what sequence number? 8, and total number of link is 2. Now I am going to add one more loop back. IP address 10.1.2.1 255.255.255.0 IP OSPF 1 area 0. Once you will add the network in OSPF, first of all it will update their database and increment in sequence number by 1. So now sequence number is 9 and link count is 3. Done. And to open router LSA in detail, so IP OSPF database, then router, and after that link ID. This is LSA header, and these are information of link, like link state. Now if anyone have question, please ask, otherwise we'll continue the session from tomorrow.